Hello everyone, this is Prasanna Patil from Department of Computer Science. So I'll be dealing with machine learning laboratory for this semester. So let's discuss what is in this lab. So you'll be having machine learning subject plus machine learning laboratory. In the subject you will be learning what is machine learning, what are the types of machine learning algorithms, and how they work throughout all the different 5 modules. So in 5 modules you will come across types of machine learning algorithms. There are 3 types. First one is supervised, second one is unsupervised, third one is reinforcement learning. Okay, one by one we'll discuss what are these different types of machine learning algorithms. And then later lab recordings. Supervised. What is supervised? In supervised machine learning algorithm, we will be providing the outcomes of a particular records, and we are making the machine to learn, giving the input as well as output, so that it can decide whenever a new example arises. So a particular example belongs to which particular category. Okay, this is called as supervised learning. That means every record or every example or every sample has been labeled. We just teach the machine, so this particular input has this particular outcome, so it will learn by taking different types of samples or different types of examples. Whenever you give a new example, so it can decide, it will give you the classified category. So this is what supervised learning. This is the next is unsupervised learning. Unsupervised learning, where all the examples we give, we don't label it. The machine itself understands by taking different features of the input and make the group of examples what we have given as a clusters. Means it separates the given examples into clusters with similar features. If I give 100 examples, and if I tell machines cluster these or separate these 100 examples into 2 categories, so it analyzes all the features and it divides the 100 examples into 2 clusters. It could be 40-60, it could be 20-80, it could be 50-50, anything. So this is what unsupervised model. Next one is third, reinforcement learning. Reinforcement learning, I'll just give an example of reinforcement learning. In gaming and in robot navigation, we use reinforcement learning examples. Okay. The types of supervised are classification and regression. Classification, supervised algorithms. Second one is regression supervised algorithms. And in unsupervised we call it as clustering algorithms. So there are different algorithms for these different types of machine learning algorithms. We'll look into it one by one. Okay. So coming to the machine learning laboratory syllabus. These all programs, we have 10 different programs. All these programs can be developed or can be implemented in Java, either Java or Python. So what we have chosen is Python, because implementing these machine learning algorithms using Python programming language is easy, because Python is very simple and portable language. And coming to the first one, this is very general algorithm to know how a machine learning algorithm works. Okay, find this algorithm, find the specific hypothesis algorithm, find very specific hypothesis. What is a hypothesis, and what is find this algorithm, what is a CSV file, what is data sample, what is training data sample. So all these will be covered in the first lab experiment. Second one is candidate elimination algorithm. So this is again a general example. So here we as I told, hypothesis. So in the first lab we are dealing with specific hypothesis, but in the second one we are dealing with specific as well as general hypothesis. Okay, this is what candidate elimination algorithm. Third one is Id3 algorithm. Id3 algorithm. This algorithm works on inductive inference principle, and this algorithm is mainly for building a decision tree. So we will be knowing what is decision tree here, and how this Id3 algorithm is used to build a decision tree. Okay, Id3 algorithm stands for iterative dichotomizer tree. So okay, iterative dichotomizer tree, we'll look into it later. Fourth one, the fourth algorithm is backpropagation algorithm. This works on the principle neural networks. So here in the fourth module we come across artificial neural networks. Okay, and artificial networks, what is different types of algorithms. There are different types of networks: a feed forward network, a backpropagation network algorithm, and how it works for different data sets. Okay, and in artificial neural network we come across a gradient descent and stochastic gradient descent. What are those? What is backpropagation? Okay, these are all different aspects of artificial neural network. Fifth one is it's about naive based classifier. So as I already told you, in supervised we come across two things: one is classification, second one is regression. So here comes the classifier. So which classifier? Naive Bayes classifier. This works on the principle of Bayes theorem. Okay, so we'll look into what is Bayes theorem and what is naive Bayes classifier. Similarly, one more example with the same algorithm, naive Bayesian classifier, with a different approach. Okay, next is Bayesian network. Again, Bayesian network, Bayesian belief networks, BBN. It's again works on the principle of Bayes theorem. Okay, and all these 1, 2, 3 we are using different data sets. Data sets means a group of data, examples, records, samples. Next, seventh one is EM algorithm and K-means algorithm. So K-means algorithm, clustering algorithm. What we are doing is we are just we are running these two algorithms on a data set, and we're comparing the results of these two, and we're concluding which algorithm suits for which particular data sets. And ninth one is k nearest neighbor algorithm. Again, k means algorithm is a clustering algorithm, k nearest neighbor algorithm is classification algorithm. In classification algorithm, we are using iris dataset. Iris dataset is a flower dataset. We have 150 different data samples of iris, and we are categorizing iris dataset into 3 categories. Okay, a classification can be 2-class classification or multi-class classification. Next, finally, we look into regression algorithm. This is a second type of supervised algorithm. So these are all the different programs comes under machine learning laboratory, and internal marks for this lab is 40 and external will be of 60 marks. Simple. And we'll look into, as we already know, as I just told you, we are using Python programming language to implement all these algorithms. To get into first lab program, before we get into first lab program, I feel it's better we know what is Python and what are the different platforms or IDEs where we can execute these different algorithms. We'll look into it in detail. First and the foremost, before we write a Python script, we'll look into what are the different IDEs are available for Python. That is very most important thing. So what we do now, we just go to Google and we just Google different types of different IDE for Python. So you'll get the link, first one, just click it, and you'll be all the different editors IDEs will be listed. And the very important thing is, in this website they have clearly given you what is an IDE and what is an editor. Okay, so here now what is the IDE in the text or code editor, and what is the difference between IDE and the text editor? Everything has been elaborated here, just go through this. And the top IDEs and code editors for Python. Top IDEs: PyCharm, Spider, just remember the name, PyCharm, Py, that means Python. Spider, it's not SPI, it's SPYDR, PyDev, IDLE, Wing, and Jupyter Notebook. So these are all different IDEs available for Python. So how do I download? First thing, PyCharm. Okay, PyCharm. Go to Google and just type PyCharm IDE download. You'll get the link, the first link, click on it. So you'll get you'll be redirected over here, and here if you have a Windows system, then just click on this and download the professional one, download, and your download will be started. Okay, cancel. Okay, if you have Mac then click on Mac and download. If you have Linux, click on Linux and download. Okay, after downloading, just install, just follow the procedures to install particular IDEs. And this is regarding Python. Next, if I want a Python compiler, okay, just type Python 3 download, Python 3 download, and there are different links available, and click on download Python, and it will be redirected over here. This is what python.org. And what is the latest Python version available is it's Python 3.8.5. If you click on this, Python will be downloaded. Clear? And after downloading, just execute it, run it, and install it. This is regarding Python for Windows, and the same way Mac OS and Linux and others. Okay, same thing. And we'll move to as I told you, there is one community called Anaconda community. It's a open source. The Anaconda community has developed Anaconda Navigator. Okay, Anaconda Navigator has access to all different IDs, in the sense Spider, Jupyter Notebook, and many different R Studios, many different tools. Okay, so this Anaconda environment, to get all these different IDs, we need to install this Anaconda environment. How do I install Anaconda environment? Just go to Google and just Google Anaconda download. So you'll get different links. Click on the first link, or you'll be redirected to Anaconda page. Click on Anaconda. Okay, click on Anaconda means this is anaconda.com, and this website just tells you what is Anaconda, and how powerful it is, and what they are looking for. Okay, what is their vision, what are their mission, and everything, and where these environment and these different IDs are used. Everything has been explained. Okay, so what I need to do, I need to download this, then I need to go to products, I need to click on individual edition. Okay, I need to go to product, individual edition, then your data science toolkit. Okay, download. Here is the download. Okay, click on the download. Anaconda installer and downloader will take you to 3 different operating systems: Windows, Mac, Linux. So for Windows, it's Python 3.8. The version of the Python is 3.8. Click on 64-bit, and you need to check which architecture you have. If you, for example, if you have Windows R, then dxdiag, type this command, dxdiag. Here you will get to know what is the architecture of your operating system. It's Windows 10 Pro 64-bit. So if your operating system is 64-bit, then you should you should download the 64-bit, right? If it is 32-bit, then you should download this. Clear? This is dxdiag, and direct DX diagnostics. Okay, DXDIAG. To smoothly run this Anaconda Navigator, your system should have minimum 4 GB of RAM. Okay, minimum. This is what once you download this, you can install Anaconda Navigator. And what is this? If you want to know more about Anaconda, so go to resources and just click on open source. So how people have made this Anaconda as open source, and what is open source and everything. We are proud to distribute and contribute to a variety of open source projects. So what are those? There are different types of technology: fundamentals, machine learning, data visualization, dashboarding, image processing, scalable computing, different NLP. What are the different packages available for different technology? Fundamentals. For fundamentals, I should go with Jupyter to know the fundamentals. Okay, to know the fundamentals, I should know the Jupyter. You should just click on Jupyter and how and all. Pandas, it's a library. Pandas for things like Excel sheet, Microsoft Excel sheet. This Pandas library is very helpful. Pandas replaces Excel sheets, computation in Excel sheets. Okay, and SciPy, scientific Python, NumPy, and numeric Python. So these are all fundamental things one should know before you go to higher level libraries, right? Before we go to machine learning, we should know the fundamentals of Python libraries. Okay. Next is machine learning libraries. What are the machine learning libraries? Keras, TensorFlow, PyTorch, scikit-learn. So these four. Okay. Then what are the data visualization libraries? Matplotlib, Bokeh, Plotly, Holovis. Okay. And dashboarding, a panel dash by Plotly, Euler, Streamlit. Okay. Then image processing, Pillow, scikit-image, and OpenCV. So there are different types of libraries available, and all these libraries are open source. You can use them and you can modify them, you can edit them. Okay, this is all these libraries are open source. Okay, scalable computing, different types of libraries, and what is the usage of those libraries will be given like this. If you click on this NumPy, the detailed description of NumPy will be available. Okay, what is NumPy? Using NumPy, what could be done? Everything. Okay, so similarly, try with all other things and install Anaconda Navigator. And once you install, the Anaconda Navigator looks like this. This is Anaconda Navigator, where you have different IDEs available here. Notebook, Jupyter Notebook, Spider, as we are familiar with these names a few minutes back. How do I launch Jupyter Notebook? How do I launch Spider? Just click on the launch button. Spider will be launched for you. This is a Spider IDE where you have uh, different sections, different workspaces. So this workspace is called as editor. Editor, where you can type, where you can write your program, your script. And the next is console. It's in IPython console. And the next workspace is help. Next is file explorer. Next is variable explorer. And you can look into history log and Python console as well as. So IPython console, you can run a simple statements here also, as well as in the editor also. So first we run a simple program. Simple program always printing something. Hello everyone. Okay, I just typed hello everyone, and what I do is I just clear everything. Okay, hello everyone, then I just save it. The program, this script has been saved as stem.py, and then I go to run, then I run it. Once I run, the output of this script will be displayed over here, okay, in IPython console. So what I had typed, hello everyone, and the same thing will be displayed. Hello everyone, I just modify this. Hello everyone, how are you? Then I save this and I run this. See, hello everyone, how are you? Okay, I can type multiple lines also. Hello everyone, I just copied and pasted. Hope you all are doing good. Then I save it and then run it. See, hello everyone, how are you? Hope you all are doing good. I can run the same thing over here also. I can run the same thing. I just selected and copied, and I'm pasting here. 1 second. Let's do it one by one. I just take the first line, copied, and I pressed enter. So here also we can execute the statements, and the output of the statements will be given right below. So this is what Spider and variable explorer. If I take, for example, I just clear this. X is equal to 10, y is equal to 20, and z is equal to x plus y. And what I do, I print z. So this is my script. I just save it and I just run. Before I run, you just observe here, we have nothing in variable explorer, right? If I run this, I got 3 variables. Okay, 1 2 3 x y z, and I have used 3 variables. And what is the type of the variable, what is the size of the variable, as well as which value has been stored in which variable. X is 10, y is 20, z is 30, and the result is displayed over here, right? The output is displayed over here, and which variable has which value, and this workspace has the information. Clear? So this is regarding Python spider. We'll move to the Jupyter Notebook in the same way. I got I launched Jupyter Notebook. So once you launch the Jupyter Notebook, the IDE will be opened in your default web browser. Default. Remember your default web browser. If your default web browser is Internet Explorer, then it will be opened in Internet Explorer. If your default browser is Chrome, then it will be opened in Chrome. Mozilla Firefox, then Mozilla Firefox. Make sure that you make Chrome as your default web browser, so that it has a very good compatible with this Python. Once I get this tab, I just need to create the compiler. Okay, new. What I'm doing is new. I am creating Python conda root. So what I did, I clicked on new, then Python conda root. So once you click on this, a new tab will be opened. In the new tab, so we have got something here. What we have got? One second. What we have got? We have got a cell here, a cell, a block, and we have got some options: file, edit, view, insert cell, kernel widgets, and save, insert below, cut selected cells, copy, new and paste, move up, move down. This is run, this is stop or interrupt, this is restart, and we have drop down here: code, markdown, raw and heading. This is keyboard for command palette, cell toolbar, publishing and editing, and this is presenting. So these are all different options. You just go through those one by one. So in Jupyter Notebook, we write scripts in the cells. Like we had editor in Spider, we have cells in the Jupyter Notebook. This is a cell or block. Okay, cells. I just clicked here and I'm typing print hello everyone again. Print everyone. Then what I need to do, I need to run this block, I need to run this cell. So to run, I have a button here, run cell. If I click on this, the output of this cell will be displayed right below. Okay, and I want to type the same program. X is equal to 10, enter. Y is equal to 20, Z is equal to X plus Y. Print Z. Then again I need to run this. So what I got, this simple. So instead of clicking this button, you also you can click on this cell and press control enter. Okay, see here the executed cell, it is increasing. If I press control enter, it becomes 5. Means I'm executing a fifth block, fifth cell, sixth cell, seventh, eighth, ninth, right? So this is Jupyter Notebook. It's very interactive. It's very simple. This is regarding your Python IDEs. So we will be dealing with uh, this machine learning laboratory using either Jupyter Notebook or Spider. So both are handy and both are simple to use. That's it. This is regarding the introductory tools for Python for the machine learning laboratory, and we'll look into the first lab program in our next video. Thank you.